Okay, so today's presentation is going to be about URISED Smart and LABUMAT Smart. These are our new products. And this is our new fully automated urine sediment and chemistry analysis system. So, urine analysis automation. Urine analysis covers the determination of chemical, physical, and sediment parameters of the urine samples. Chemical and physical parameters can be measured automatically since the 80s by automated chemistry analyzers, so-called strip readers. And sediment parameters are still measured in many laboratories by manual microscopy, which is still the reference method, even though it has certain drawbacks, such as the sample preparation and observation or observator variability is depending on the operator. It involves manual data handling, which makes it prone to errors. It has a high coefficient of variation, which leads to poor reproducibility, and significant human resources are necessary, and it's quite a time-consuming process. So for that reason, we created LABUMAT Smart and URISED Smart, which is an affordable solution for low or mid throughput laboratories. It is using a proven technology. The minimum sample volume are 3 milliliters. It has a common quality control and a common database. It requires a single LIS or HIS connection. And it has an intelligent track moving system, which means in certain circumstances, the system can roll back racks and remeasure samples. And it has a new handy stat position for important samples. And as I have mentioned, it's an affordable solution for small and medium-sized laboratories. And the throughput is more than 100 samples an hour, which might be even an overkill for smaller laboratories. The other good news that the system is using the same cuvettes that you would use for URISED 3 Pro. So if you would like to use it as a backup system, that's also really easy, because you would need the same consumables for both the sediment and the chemistry part. So speaking of chemistry, it uses the LabStrip U11 Plus GL and LabStrip U12 MALP CRA. So I'm holding this presentation in a way that everybody can understand, even those who have not used URISED technology before. So about the URISED technology in general, URISED makes traditional manual microscopy automated, reproducible, and standardized. It does not require any special liquid reagents. It has a very cost-effective operation. So the only consumable are the patented cuvettes and ordinary distilled water. So you wouldn't need ultra-filtered distilled water that you would use for a biochemical instrument, just distilled water. It will provide you whole view field images that are available to the user for further analysis. And these images can be used for educational or research purposes as well. So about the URISED cuvette, here's a very enlarged photograph of it. It is a patented special measurement chamber, which is made of polycarbonate for single use, and the chance for carryover is near zero. Those who are familiar with the URISED Mini, which is a semi-automated instrument, you know that if you are changing the pipette heads while you're pipetting the sample into the cuvette, the carryover chance is exactly zero, because there's no way that you can contaminate one sample with the other. I would call the attention to this is the hole where it's get filled, and there is the other hole, so the liquid fills this way and goes to this snake-shaped structure with a double curvature, and there it has an other hole where the excess is aspired off by the automated instruments such as the 3 Pro and the URISED Smart. So about the measurement sequence on the sediment part, the sample homogenization in the test tube is the very first step. Then it's filled into the cuvette. Then sedimentation happens with gentle centrifugation. Cells do not lyse. For reference, here we do the centrifugation for 10 seconds. Any other urine centrifugation technique involves almost like the double G, so this is 260, and normally you do it in 400 G for 5 minutes. So we can see the difference between 10 seconds and 5 minutes with half the force. Next step is the cuvette is placed in the microscope, and automated focusing happens at each image. I'm saying in the microscope because the optical system is below the cuvette and the lamp is on the top. Then 15 high-resolution images are made while moving the cuvette. And there's a AI-based image evaluation. We are using this technology since 2007, so this is not a marketing plot here. And finally, these images are stored, displayed, and transferred alongside the results. So details of the URISED Smart. It is capable to do 100 samples an hour. It makes 15 high-resolution bright-field digital images, so it has no phase contrast technology, hence it is affordable. It has a patented cuvette-based technology, dedicated stat position, fully automated measurement sequence, only consumable is the cuvette, and there is no need for calibration or reagents after installation. So here is the particle list. So these are the formulated elements of the urine that URISED Smart is capable detecting. So it has 16 automatically recognized particles. There can be 5 user-defined particles, and there are 2 result flags, the mucus and the bacteria, and there is a custom user-defined flag, the UTI flag. We are going in detail later about those. So let's proceed to the chemistry analysis part, which using the reflection photometry technique, the illumination happens with 4 LEDs with discrete wavelength. The detection happens in these 2 photodiodes, and there is a third detector which is used to follow up the aging of the LEDs. And so this is also a patented technology to prevent any inaccuracies due to light intensity. And once we have the reflection signals, these values are always compared to a factory calibration and processed. So about the test strips, the good news is that we are using the same lab strip U11 plus GL and lab strip U12 MALB CREA with the standard parameters. As we can see, the difference is the creatinine and the albumin pad on the U12 MALB CREA strip. And here the SG is in brackets because this is measured by the physical measurement cell. So this is here is used as a reference pad only. Another detail about protein and albumin detection, because I feel it's necessary to state what's the difference, what's the importance of the albumin pad. So protein pads are not selective for peptide bonds, but rather certain proteins. And albumin pads are highly selective for albumin, even less prone to interference. And so we use for a docu-reader, we have a small 2-pad strip. The third one here is also a reference pad, the lab strip U MALB CREA, and then we have the lab strip U12, which we are speaking of now. And as you can see, the limit of detection difference is 10-fold. And also the microalbumin pad is the recommended method to follow diabetic nephropathy by the American Diabetes Association. And it is also very useful in the management of diabetes, following up how successful the treatment is, because if there is albumin leakage reduced, we can say the therapy is going well. So let's go through now the measurement sequence. So when we are preparing for the measurement, it's very, very easy to use. No pre-treatment such as centrifuging or staining necessary. It has a very quick startup. We just measured, like, depending on how fast you type in your password, the LABUMAT Smart, URISED Smart can start within 2 minutes, so a minute and a half should be enough for the first measurement, which is supposed to be quality control, of course. But this is how long it takes to boot the system up, and it has no awake time or whatever. There's an initialization if you stop the measurements and would like to continue later, but that's also way below 60 seconds. So back to the sequence. First, you need to fill up the wash container with distilled water. Check if the waste is empty. If not, please make sure it is empty, so you will have plenty of room to do measurements for the day. Those who have experience with LABUMAT 2 and URISED 3 Pro, this has only one wet system, so one wash can and one waste can, but of course you can put two if you'd like to. Normally we ship it with one set of these cans, which also require less space then and easier handling. Afterwards, we need to, so once we have the wash water, we need to load the cuvette holders and the test strips, so the consumables, and then we just need to put there the racks with the sample tubes. So as I have mentioned, only one wet system. Make sure the waste tank is empty. So with the strips, you have a QR code in the tube, or it comes. We also ship it with a QR code for the entire batch, so you can register more strips than a vial at once. But normally you would just need to hold the click registration, and then you can also type in the code for the strip lot or the vial, and you can also hold code in just in front of the hole with the QR code, and it will be red, and you need to load the test strips facing inward. So very simple. You remove the cap from the tube and just, so to say, chuck the strips in. Very easy. You don't need to worry about orientation because it's already orientated correctly. I'm sure there will be a question about strip stability within the instrument. We are currently doing the confirming experiments. But so I would say now, just to make sure, it's 1 day. So you don't, if you know that you're not going to use many strips, so you are not going to have many samples that day, I would suggest don't load an entire vial. And you can also place the cap of the vial here. We are going to ship 100 or 200 gram desiccant bags, a big amount of desiccant, and that, as I have mentioned, we have not confirmed it yet, but those supposed to make sure that the strips that are loaded in the instrument are going to last for at least a week. So I will let you know about removing the strips at the maintenance part. So what happens software-wise here with the consumable registration, there is one button, and then you need to select which instrument you're going to load with consumables. Here, chemistry is selected. So as we can see, once you click OK, you will have the pop-up message. So you can write here the number from the strip case, or you can scan the QR code. You will have a pop-up if the registration code was accepted. And then you can load the strips into the strip holder. And after that, please kindly close back the latch. So cuvette registration. In this case, you select here registration. Of course, it goes into the sediment instrument, and then there will be a pop-up if you'd like to read the cuvette magazine tag. So here you can see there's a little white square that is the RFID tag, and now we are facing just from the instrument, which is opened on the image. And here is the reader. Now we put also white RFID sign on it to make sure people know where to put it. So I click registration sediment. I have the pop-up. I say okay and read the RFID tag, and then I load the QX holder magazine. It's exactly the same system as in the URISED Mini. So it has a little plastic seat which is embedded on a metal bottom, and on the side there is a small click which you need to press when you are inserting the magazine. And once it is in place, you will need to remove the Tixa tape. Make sure you only remove the Tixa tape when it's in place. Otherwise, all the cuvettes are going to fall off the magazine. So now that we have all the consumables loaded, we have distilled water, say we have measured already a QC, now we can be ready for the measurement. So we go to the measurement tab. We double check if both instruments are online, and we press the measure button. And then we will have a pop-up window. If we would like to measure sediment or chemistry or all, we set all, so both chemistry and sediment will be measured. If we select sediment only, you will need to place the test tube rack on the sediment instrument. So you, as you're only measuring sediment, we don't like to travel it through the chemistry. So if you are selecting this one, please place there your racks with test tube. Otherwise, everything starts on the chemistry side. Just 1 second, because people are still coming and I'm trying to let them in. So this is the way that you place the test tubes if you starting the measurement for both sides or the chemistry side. So here we have the chemistry instrument, and as you can see, you can load 5 racks. The minimum sample level is still 3 milliliter for common measurement and 2 milliliter for sediment or chemistry only. There will be a pediatric or low volume mode. I will talk about it later. So as you can see, here you can load 5 racks, but there's room for a 6th. But the instrument will tell you to remove the 6th one, because this part is needed for the intelligent rack handling. So if it would need to roll back a rack, that would be the way. So this is why we can only load 5 racks at once. So now that we understand how to start measurement, let's go through the QC, because we still recommend daily QC on the instrument. So if you go to so here I think the software looks familiar for many users. Here we have the quality control, and the good news, to make your life easier, you have one page to fill the chemistry and sediment data of the quality control solution lot in one page. And so this makes it easier to make sure the same lot is selected for both sediment and chemistry. once you loaded the data, you need to select, so you have the star icon next to the selected QC lot, and finally you will need to press Start QC in the bottom. So when you're filling the QC solution, make sure that it is room temperature, and make sure it is well mixed. So slowly invert it 20 times. Don't shake it, because then it will be frothy, and that's not decent for the quality control measurement. And once you fill the QC solution to the test tubes, for the common QC at least 3 milliliters, you can place first the low and then the high QC into a rack, press Start QC. It will again ask back if you have loaded it in a correct order, just to make sure. And then you will be able to check the diagrams for certain lots, or by pad for the chemistry. So let's go through now the measurement sequence of the chemistry part of the instrument. Here on the images, it will be mostly with open door, so you can see what happens inside the instrument. So first, the sample is identified by the barcode. Then the sample is mixed. It's 1 aspire release cycle for the chemistry and 3 for the sediment. Single measurement requires 2 milliliter. Combined chemistry and sediment 3 milliliters. So how the mixing happens is during it, the sample aspiration takes place around the surface of the sample and is pushed back to the bottom of the tube. Thus, the less concentrated sample is pushed to the bottom of the tube, where the sample may be more concentrated, considering gravity. So how it happens, this is our sampling pipette. First, there is an air bubble, and then comes the sample. And here we have the distilled water, which is going to wash it afterwards. So aspire release, aspire, and then it is dosed on the test strip. It's a precise amount on each test pad. And then the pipette comes to the front. So probably here you can see better there's a hole, that's the pipette washing well, and the pipette goes in. So it is washed from the inside and the outside between every single measurement to avoid carryover. Again, this is done by the system distilled water, so no detergent or special treatment needed for the pipette. And so then the strips are incubated for 60 seconds, and the measuring head reads the color change on each pad. And as you can see, this black box on the top of the pipette contains the physical measurement cell, whereas we have 2 chambers. The top chamber has LEDs, again 4. And so here's the sample in the middle in this tube, or I know it's misleading, but we also call it a cuvette. So practically this is the inside of the top of the pipette, and the LEDs go through the sample, so there are detectors for turbidity and color. And the lower chamber has a laser light source, and this is to shoot through and be detected on the other side. So this is to measure specific gravity, or in other words, relative density. So about the measurement sequence and result handling. So the semi-quantitative results for each pad are calculated based on relative reflectance values. So for LED3 sensors, complex calculations are made to achieve more precise color detection. Physical results are calculated and displayed also for all samples. Then the user can validate the results, which depends on the validation settings. We are going into detail later, and then the data can be sent to the LIS or HIS. And if there was no barcode used, providing the same ID for chemistry and sediment results, we are unified them. So you just need to change the name of the sample. Be careful because you cannot undo this. So practically, you would need to rename the separate chemistry and sediment sample both to say patient 1, and then it will unify the results. So here are some more details on the chemistry analyzers that I have explained roughly before. So here we have the 4 LEDs with the discrete wavelengths. Here is the test strip. Here is one pad of the test strip. So the pad is illuminated. The light is reflected to these 2 detectors. And then I said this is the third one for aging compensation, and then the reflectance values are going through the signal processing system, and that is going to calculate and compare it to calibration standard, and this is how we get the results. So here's the physical measurement cell again. And so finally, the system is going to calculate and evaluate from the reflectance values and compares it to the defined range limits and produces semi-quantitative results as standard in urine chemistry. So again, just in previous instruments, the logic is the same. Chemistry results on the right, sediment results on the left. And so this is how it is transparent and easy to interpret. So just to go through again quickly on the chemistry measurement sequence. First, we read the barcode, mix the sample, then strip comes into pipetting position, and a certain amount is pipetted on every single pad, and then the measuring head reads the color change for each pad. Pardon, sorry. So again, barcode reading, sample mixing, pipetting position, and then happens the pipetting sample dosage for each test, I mean for each test pad. Then incubation comes for 60 seconds. Meanwhile, the pipette is cleansed. The measuring head reads the color change of each pad. Then the physical measurement cell is performing its measurements, and then the results are calculated and displayed. So let's go through the measurement sequence for the sediment instrument. Again, sample identification happens by the barcode, sample mixing repeated 3 times to make sure all particles are homogenized. So this is a little more thorough sample mixing than on the chemistry. Minimal sample volume for sediment only is 2 milliliters, but as I have mentioned, common measurement 3 milliliters, just like on previous instruments. So the rack is forwarded to the sampling position. the pipette comes out, while the barcode, the sample is identified by the barcode, and homogenization happens in the test tube. And then, as we can see here, is the cuvette, and the aspired mixed, well-mixed urine is filled into the cuvette. The volume is 175 microliters, and the excess is aspired off. And then comes the sedimentation. So here we have a cross-section of the cuvette, and here are the floating formulated elements. And afterwards, we will have it in the bottom of the cuvette, so they will be in one focus layer. We have here the same pipette cleansing method. So this is the pipette washing well here, and it is so the pipette is washed, as I have mentioned previously, from the inside and the outside as well. So virtually we shouldn't have any carryover. Performing the measurements, so the cuvette is moved around. These dots signifying the places where images are taken. As you probably can see with a very quick glimpse that these are 20 positions, and we only make 15 minutes. That's 15 images. That is because we have an automated bubble detection system. So if the image would contain bubbles or such, then the cuvette is moved into the next position. So we will have a decent image. There is automated focusing in each positions, and this is how we get good quality images for the measurement. So after the images are recorded, the AI is going to evaluate it, and you will have the results displayed on the left side. And here in the bottom, you have a preview, which if you double click, you get into the you can go through, and also here there is the gallery, so you can see the 15 images at once. This feature is also very useful for troubleshooting. Say the microscope lens are dirty, and you will always see that dirt on the same image from each sample. So this is I find it a very, very useful feature. Okay, a quick recap of the measurement sequence on the sediment part. So barcode is read, sample is mixed, pipetting, position pipetting. Then the sample is aspired, filled into the cuvette. Then happens the sedimentation or centrifugation while the pipette is cleansed. The cuvette is moved above the microscope, and the images are taken while moving the cuvette. Then the images are evaluated, and results are calculated and displayed. So now let's go through the software. So it has the old and new login system. We will get into details later. So now, as you can see, we have service or administrator access, as we have all parts of the settings accessible. So in first tab is the category tab. where we can change the cutoff values. All our cutoff value, so all our default cutoff values are in line with the 2023 EFLM Euro-analysis guidelines. So this is the European guideline. The CLSI, so the American guideline, does not provide any suggestion of on the cutoff, so we can't comply with that. And I know that there are many health authorities in the world, and they have their own cutoff values, because as we know in urine analysis, given that it's mostly semi-quantitative, we don't have internationally recognized cutoff values, so they may differ a bit. And also it depends on the health authorities often how many categories, for instance, you need to put your results. So this is why it's a very highly customizable part. Yeah, so please make sure you meet with your laboratory standard or your customer request on the cutoff values. So you can adjust not just the limits, but the number of categories and so. So the next tab is the display tab. This is where you can change the language, have a ruler, but most importantly, here you are going to be able to set the measurements units for the sediment, so part pro high power field or part pro microliter. And here you will be able also to customize a little bit the columns that you have in the database. And yeah, time and date, so some other basics settings you find here. Next up is the service tab, which is where you can set up the old, so-called old and new login system. So the old system means that you have 3 users. You have one administrator, one service, and one operator. The operator has no access to most of the settings, and the other 2 has. Or you can use the you can use the new login system where everybody needs to create a username, and you will have only 2 users still who has access to as a like service and administrator, so to the settings. All the other users will have their names. So if you'd like to follow who did what on the instrument, or who modified, for instance, a sample, then you can do it by using the new so-called new login system. Otherwise, this tab in the settings is mostly for service people. They know how to deal with it. So the next one is the measure tab. So here you can set firstly the database limit. The database limit is 10,000. We suggest to keep it around 5,000. That's already a lot of samples, and it makes sure that the software runs fast and smooth. Here you can generate warning if you have so if there was no barcode, hence the ID was generated. And here also can set the repeated barcode checking, as in certain laboratories, and they use the same barcodes over and over. So you can set it here with the time limit. Then you don't confuse, for example, a rack that you have previously measured on the same day. And here you can also set validation. So all samples are auto-validated, no samples are auto-validated, or only negative, and skip samples are auto-validated, and no auto-validation if the ID is generated. So it calls double attention to a sample that had no barcode. Here you can also set up the worklist function and have predefined comments. So when you want to comment a sample, you don't need to type, you just need to select it from the predefined and put it on the sample. Next one is the maintenance tab. Here you can, of course, name your laboratory. Here you can see the users that you have as special, like this is the old login system, but here you can add new users or modify users if you have the new login system. I would recommend to shut down the PC at exit unless you would need to have save the database or load back a database. For whatever reason. Here you also have a QC result deleting, which means that beside of the last valid QC, you would delete all old QC results from the database. And here you can set up an old a QC lockout QC lockout as well. So if you don't have valid QC, the instrument is not going to measure. And here you can also set up like backups and restore old backups as well. So next up is the print menu, where you can, of course, set your logo and set the printer if you need to print the results. The next one is also, again, rather for service people. Here you can set up the transfer type with the laboratory information system. And what is important for us application people is the after send enable modify in the button, which means that say you have a sample and it's valid, so it is sent to the LIS, but later on you are reviewing it for whatever reason and you change the particle tags on the sample. So you modify the sample. If you enable this feature, the modified sample will be sent again to the LIS and will be dealt on the LIS, how the LIS is programmed for that. So I believe there are not too many laboratories who require this, but if you do, you have the option. So the other part that might be important for us is how would we like to have our data exported with images, quick export, or with extended information, which includes cuvette lot and so and so. Okay, so next one is the smart settings menu. As I have probably mentioned previously, that you can use the URISED Smart standalone, but you cannot use the LABUMAT Smart standalone as it has no PC. So it won't function, as simple as that. So I'm sure many of you are going to be familiar with this. from the LABUMAT 2. So this is a very concentrated menu of it. So here you can, in the chemical categories, you can change the name, or if you would like to have trace categories, if the box is ticked, then the trace categories count as positive, and if these boxes are unticked, the trace category, sorry, here it's so if the box is ticked, it counts as a positive sample, and if the box is unticked, it counts as a negative sample to have trace amounts of certain chemicals. Here you have the fail-safes, such as the dry strip check and the stop on failed measurement. I would recommend to have the dry strip check on, and the stop on failed measurement means if you have any of the X error, so if the strip is flipped or whatever other issue it has, then it will stop on the first error. So this is how you prevent wasting many samples and consumables if the strips are are loaded in a misaligned manner. This again depends on how experienced the users are. Here you can also set the units for the chemistry results, how you want to display. And here you can also set up the criteria for measurements. So measure all samples, which is recommended, measure work list sign samples only, or measure positive chemistry samples only, which means only those samples are going to measure on the sediment part that were positive for whatever pad on the chemical part. I personally do not recommend this because, for instance, if you have non-squamous epithelial cells, which can be a sign of very serious kidney injuries, and for some reason there is no accompanying bleeding, then you will have negative chemistry and you don't measure the sediment, so you don't see these symptoms in the patient, but it is up to your laboratory. And finally, we have the evaluation tab in the settings, whereas you have all the particles, and you can turn on the extended particle list, so you can manually tag many of the other particles. And on the right side, you have the UTI flag. So the UTI flag is, I think, a very good feature, because by default, it will be triggered if the lowest cutoff for white blood cells and bacteria are met. You can change this and to or, so and or. How is it useful? It is useful in a way that, say you measured your first few thousand samples, you send some of these samples to microbiology to check the culture, and then you have a data set, and from that data set you can extract which were the true positive samples for microbiology culture, and which were the false positive samples that were measured, but no bacteria could be cultured. So you set your flag accordingly, and then you can save on microbiology culture budget. If you like to make a case study, then I would suggest to measure at least 1,500 or 2,000 samples, make culture of all of these samples, and then you will have a very good data set, so you can set the rule accordingly. And this is the way that you make sure that you won't have any false negative samples, so that would, that you wouldn't measure, but still seemingly reflect to growing bacteria in the urinary tract. So that's the use of it. The other two flags are also customizable. So that is the mucus flag, which means that you will have a little circle, red empty circle, saying that there is a lot of mucus in the sample, which means that some images or some particles might be defocused, as mucus is not going to sediment to the bottom of the cuvette, whatever you do. In most cases, it doesn't cause any problem. Just to be on the safe side, you can use this feature. And then there is the bacteria review. So if there is a huge amount of bacteria, this will be triggered. And then you have finally the cross-check rules, which to avoid confusions, I would very strongly recommend to have disabled, and they are disabled by default. So you have the overview screen where you have the PMC calibration, which needs to be done every month, and you can follow up what strips are registered into the instrument, and of course you can select between them, so you can register both strip types. Just make sure you select the correct one. And here you can export the raw data for the LABUMAT Smart, so for the chemistry. Next up, I would like to talk about the stat position, which is very, very handy, even though this is not a very lifelike image, because we use the stat position when the samples are processed. This is just for visual clarity. So in normal measurement mode, say you are measuring and you have one very important sample, you put it into the stat position and you just press it inward, and then the ongoing process is going to be finished, and then immediately the stat sample measured. Of course, we are planning to implement our very popular live view into this software as well, which means that you can have a live view and you can make your own photos, and you can move the cuvette around as you wish. If you're looking for a rare particle, or you would like to see things in motion, for instance, you're looking for trichomonas, and also the low volume or pediatric mode will be, which will be also soon implemented, will be accessible from the stat position firstly, expecting you don't have a huge volume of pediatric samples. Next up is refilling the cuvette's measurement interruptions. So once, as we all know, the cuvette magazine can hold 50 cuvettes, and hourly throughput is 100 sample. So it means you have, and you can load at once 5 racks, so 50 samples. So the magic number here is 50, which is supposed to be processed in 30 minutes. And then you would need to empty the cuvette bin and load a new cuvette magazine. So you will have a warning that the instrument has run out of cuvettes, and then the instrument says it's stopping. So please do not open the door while it says it's stopping. Make sure it's in the continue mode, and then you can quickly change the cuvette magazine. So about the sediment and chemistry results. As I have mentioned, chemistry is always on the right side and sediment is always on the left side, and here you have your samples. So you can modify these results. Let's go through the sediment modification. So you can modify them on a label level. So you can go onto an image, delete or change certain labels or put down new labels when you feel the automated labeling is incorrect, or if you would like to subcategorize, for instance, red blood cells or non-squamous epithelial cells, then you can do it manually. We of course recommend this to use in small specialty labs where you have a few samples a day. You don't want to do this, and luckily you don't need to do this because the automated labeling is accurate enough. Then you can also modify the sample on sample level. This is that you just one second. I'm going back to this. So you select here a sample, and in the bottom you go to modify, and then you will have a pop-up window, and you can modify the dilution factor. So if you have a crowded image, so you have a crowded sample, and say it's all blood, you have two options. You can put 4+ blood and that's it, and you don't need to measure it again. And the other option, if you're curious like what is behind the red blood cells, then you can dilute it. And if you're diluting a sample, I very strongly recommend to dilute the sample 10-fold. So 1 part sample, 9 part physiological saline. We did experiments on this, and in most cases, the 10-fold dilution is the ideal one. Yeah, and you can also, as I mentioned before, so you can modify the final results. So if you don't want to deal with dilution, you just change the average number of particles, or I would rather recommend just to use the semi-quantitative categories, so 4+ blood, and that's it. So here's the results review. So if you see the yellow square with an exclamation mark, it means that the sample level was low, so it was still measured, but the sample mixing might have been incomplete, and this is why you possibly don't have even particle distribution. So what it will result in, that you will have invalid results, and you can review the images and validate them one by one, and then you have automated results. The next sign is the black square, which means the cuvette is empty. This can also happen when you fill distilled water or into the cuvette, or if the urine is like really diluted. It's a software solution here as well. So basically, if there were nothing found on the images, it will be flagged as empty cuvette. And then we have the bubble detect system that I have mentioned previously. This is why we have 20 positions and not only 15. So if a bubble is detected, an algorithm runs and just move the cuvette into the next position. And this is where the image is recorded, unless if there's a bubble, it goes to the next, and so on. And then you have the review flags, the full red square and the empty red square, which means that not all images are valid. So let's go into detail of how this goes. So if you have 0 to 2 review images, which means for whatever reason the image could not be auto-evaluated, that means nothing. That means that the results are results calculated are based on the non-review images, so it can be auto-validated. You won't even notice, just it will be, say, 13 out of 15 images. If you have 3 or more images to review, but you have at least 5 valid images, you will have a soft review, so the empty red square. This means that the results are calculated based on the non-review images and cannot be auto-validated. So if you, finally, if you have less than 5 valid images, you will have a hard review with a full red square, which means you are not going to have automated results and the sample cannot be auto-validated, but you can modify the final sample results based on the manual review of the images, or you can remeasure the sample. Of course, I would suggest here the tenfold dilution. And then you have the user-defined flags, so the mucus review and the bacteria review. These are optional, so a high concentration limit can be set for either or both of these parameters. And if the sample result concentration is above this limit, the measurement will be flagged for review, and you will have these beautiful signs notifying you. And then then you will need to manually validate the images. And about the UTI flag, I think I have already went into detail. So now let's see a few examples. So in the first in the first example, we have the second and the 12th image for review. So that's 2 images to review. Jolly good. We have 13 valid images, so the evaluation happens. In the next example, I have 3 images to review, which means I have at least 12 valid images. So there goes the empty red square, soft review. I will have automated results, but I need to manually validate the sample, as also in the next 2 examples where I have 4 and 10 images to review. I mean 9 images to review, and then sorry, it's 10. And then I can go through on these images and so practically manually review them. And if there's no big difference on the review images than on the valid images, I can comfortably validate them manually. And then finally, on this one, I only have 4 valid images, which means a hard review, so there won't be any automated results viable, even though if I validate, but I can set, of course, modifying the parameter, like say 5 plus blood or 5 plus white blood cell, and then I have results to send, but here I'm entirely liable for modifying the results. So how the result modification happens, that I select I select a parameter here in the sample, in this case red blood cells, and I can change the average number of the image, or I can change, and I would suggest this, the semi-quantitative category, so 1 plus 2 plus 3 plus 4 plus negative by default. So there's three types of result validation. So there's three approaches, and this is something that is up to the laboratory protocol or standard. So one where is all samples are auto-validated, except of course the four review ones that we've been just talking about. And then there are the only negative samples are auto-validated option, or none of the samples, sorry, I will correct the typo. So none of the samples are auto-validated. Validation is necessary to export a sample and or to send it to the LIS. So this is why it's important that you have your samples in one way or another validated, because only these samples will be sent to your network. And of course, if you use the none of the samples are auto-validated, you can select the samples by Control and Shift. So just if you use an Excel or frankly anything on a computer, and so you can select multiply samples and click validation as well. So this is the most frequent question that we have. How can be the chemistry and sediment result discrepant? The answer is very simple, even though sometimes it is not easy to explain to users. So the two measures, urine chemistry and urine sediment, are practically measuring two different measurements. So for urine chemistry, we measure hemoglobin content, and for urine sediment, we measure intact red blood cells, and for chemistry, we measure leukocyte esterase content, and so this is an enzyme content, and for sediment, we measure intact visible white blood cells. So the number of erythrocytes and leukocytes which are detected by the sediment analysis may be lower than the result of the test strip. That is because lyse cells are not detected by sediment analysis, and the number of erythrocytes and leukocytes detected by sediment analysis may be higher than the result of the test strip, because perfectly intact cells, so the urine is fresh and not detected or detected low by the chemical analysis, because they had no time to release hemoglobin or enzyme into the sample. So we are approaching the final part of the presentation. So let's review the instrument as if we were looking at it from a close-up. So the waste bin capacity for URISED Smart is 50 cuvettes, and it can be, so the waste bin can be opened without opening the door. And please wait until the intelligent track handling systems clears the racks from the area. So, or you can remove the samples. These samples arrive here, so these samples are all measured. You don't need to worry about them. Just remove them, and then you can open the bin. So here, this is what we see if we open up the door. Here is the cuvette hold-down assembly and the cuvette moving arm. And this is a side view. So previously we were watching it from here. Now we are on the side of the instrument. Here we have the cuvette holder magazine with the stand. Here we have the centrifuge. Here we have the second cuvette moving arm, which is moving the cuvette from the magazine here, and that by the other arm that we have seen is going to move it above the microscope lens and move it around. And here is the cuvette slide. So, and here's the bin. So the cuvettes are sliding through here into the bin when after the measurement. So now on this image, I have removed the cuvette holder, and you can see here the second cuvette moving arm. I am showing this because so as part of the daily maintenance, you don't need to clean this every day. And of course, here you can remove the second cuvette moving arm. Those who have used URISED Mini will be very, very familiar with this part of the instrument because it's exactly the same. So you don't need to remove it daily. Just please make sure you check every day if it needs cleaning or not. So here's, again, we are in the front view. So here's the lamp, here's the microscope lens, and of course, down here, yeah, here's the microscope. So disinfection, the daily disinfection happens that you press either the exit button or the disinfection button. You can select if you want both to disinfect or just either of the instrument. Make sure you fill a test tube or just regular test tube with 2% sodium hypochlorite and use 7 milliliters of sodium hypochlorite solution to clean both of the instruments. 3.5 if you have only a sediment part, but for both instruments you will need 7 milliliters of bleach. So make sure you remove all the remaining racks from the rack conveyor unit and the rack handling system, and then you should have there just one rack with 7 milliliters of bleach. And then you start the disinfection from the software. So tap the exit button or go to general and disinfection and wait until it's finished. This should take about a few minutes. And if you remember, if you said exit upon exit and shut down PC, it will turn the instrument off automatically after pushing the instrument, and then you can do your daily maintenance. So speaking of maintenance, these 3 or 4 parts are removable easily. So the centrifuge cover, the centrifuge arm, and the cuvette hold down assembly. So make sure you clean this with an alcohol-based and iodide-free detergent. So your normal laboratory detergent should be fine. Just make sure it contains no aldehydes. And then you have the cuvette bin. You can also clean this with the same detergent or use bleach. This is not a sensitive part, so whatever. And here is the magazine, so the cuvette holder as well. So here's a slide about cleaning. So make sure the cuvette moving arm is clean. So this one and the other one here, I would say just check it every day and only clean them if it's necessary, because improper cleaning can do more harm than good. So just check it, and if they're not dirty, just don't worry about it. So when you remove the magazine, when you remove the cuvette holder, don't remove the magazine or the cuvettes will fall out. So when you remove the cuvette holder stand from here, so this part, the cuvette moving arm will be this position So in order to thoroughly check it, put your finger on here and press it backwards or pull it backwards, and then you will see it entirely. And if it's clean, fine, just push it back here. Otherwise, you won't be able to put back the cuvette holder seat. And if you feel it needs cleaning, take it out. It has one pin which goes into a hole. So take it out, clean it, make sure it's dry, and then put it back in and make sure you press it here towards yourself, because otherwise you cannot put back the cuvette seat. The cuvette holder seat. And here's the microscope. So this is also that you should check daily, but make sure that you only clean it if necessary. And for this, please use a lint-free cloth and 70% alcohol, so no detergent. The microscope is the most delicate part of the instrument. It is very expensive to change, so make sure that only proper cleaning happens here. Please educate your users accordingly. So this part, I repeat, can be only cleansed with a lint-free cloth and 70% alcohol. Okay, so other part of the daily maintenance, please make sure that you do the cuvette slide, because of course there will be spillage, and so yeah, just use your normal laboratory detergent. Okay, also another thing, so this is again the side view, but you can place the instrument from this side next to the wall, and then you don't have this side view, but from this side it's easier probably to check the second cuvette moving arm. Okay, so now this an overview of the rack conveyor. The rack conveyor is very sensitive. It's almost impossible to flip a rack over, so don't put anything on the side, because unlike for the big automated systems, so 3 Pro and LABUMAT 2, here, if you spill something on the rack conveyor and it goes here underneath the start position, then there is a printed circuit board. It will be a very, very expensive repair. So make sure there is no spillage on the rack conveyor. So it has 4 RFID readers. Now we have like a white tag, so you know that you need to register your cuvettes here. And this is how, just to repeat, this is how it looks with fully loaded with the 5 racks to start your day. So LABUMAT part maintenance waste bin capacity is 150. I think a little more can fit it, but like whenever the warning says empty it, please empty it. You don't need to open the door. You just need to wait till, because, okay, so here are your racks and here is the bin. So whenever you have the warning, make sure you don't put more racks here. Otherwise, you would need to remove them and put them back. So then now you have access to the strip bin and you can empty it easily. Now, let's go inside the chemistry instrument, the LABUMAT Smart. So here's the strip holder. Here's the pipetting station, which is now has blue color, so it's much easier to see. Here is the washing valve, and here is the comb. And here's the pipette, and on the top there is the physical measurement cell. So this is what we see when we open the instrument up. It's the same image just with the open door. So internal parts that you need to clean will be the pipetting stage and the comb mostly. So here in this black box on the right side, we have the measuring head. And this is a very strong magnet, so to make sure that it, and plus it has two, so the comb has two pins to guide it to the perfect place. But you may open the measuring head. So this is really crucial. Underneath, you have the reference pad, okay? This is something that is not really visible on LABUMAT 2, but on the Smart, it is here and accessible. So make sure you don't clean it, you don't touch it, and you just try to avoid it, because this is, again, a very sensitive part, and if anything changes its color, all your measurements are going to be false. So make sure you don't touch, clean, or in any other way interfere with this part. If you need to open this up to remove the comb, if not, just don't open it, okay? So pipetting stage, comb, and the bin, these are the things that you can remove from LABUMAT Smart, and please make sure you clean them with a laboratory detergent that is alcohol-based and aldehyde-free, and just like the URISED Smart or any other 77 electronic instrument, make sure everything is dry before you put them back, because vapor can use a lot of issues, especially in the chemical instrument. But it can also sit on the cuvette. So yeah, just make sure everything is dry before you put them back. Before I thank you for your attention, I'd like to show you one other thing. Here are these two, I would say, guiding rails also. So whenever you open the LABUMAT Smart, make sure that there are no spillage, no sticky surfaces, because if there's any spillage, it's going to be a sticky surface, and that might misguide the test strip. So please make sure that you check, and if necessary somewhere, just please clean it. So I would like to thank you for your attention very much. And now I'm going to check the chat. We finished the recording, maybe start a new one. And I'm going to check the chat for questions. And after a short break, so say I will be back in 5 minutes. Okay, I will review the questions in the meanwhile. I will unmute everybody, and we will continue with your concerns, questions, doubts, and requests. So see you in 5 minutes, and thank you again very much for your attention.